Good day, everyone. We are Modula and Podrick.
Let's dig into what is going on in tech and science news.
All right, we are diving deep, and I mean deep into the Indian Ocean. Why? Because we're going to investigate one of our planet's most fascinating and long-standing mysteries, a massive gravity hole. What in the world is it, and how did it get there? Let's crack this thing open. So before we get to the Indian Ocean, let me ask you something. We all learn in school that gravity is this constant, predictable force, right? But is it really the same no matter where you are on the planet? Yeah, the answer is a big nope. It turns out Earth isn't some perfect, smooth sphere with all its mass spread out evenly. Honestly, it's more like a lumpy potato. Deep inside, you've got materials with different densities, and that creates these patches of slightly stronger and slightly weaker gravity all over the globe. To actually map out this lumpiness, scientists use this incredible model called the geoid. Okay, just imagine for a second that the oceans were perfectly still. No tides, no currents, nothing. The shape that the water would take, pulled on only by gravity and the Earth's spin, well, that is the geoid. It's basically a secret map that shows us where mass is piled up or where it's missing way, way down inside the planet. And this brings us right to the star of our show, Earth's most dramatic, most extreme gravitational feature, the Indian Ocean Geoid Low. People just call it the IOGL. This thing, this massive gravity hole, has been a complete scientific puzzle for like 75 years, ever since it was first spotted way back in 1948. So how big of a deal is this gravity hole? We're talking about a dip of 106 meters. Now, let's be super clear, this isn't a physical hole in the ocean you could fall into. What it means is that if you could magically smooth out all the waves and currents, the sea level right here would be 106 meters lower than the global average. That makes it, by far, the biggest gravity anomaly on the entire planet. Okay, so what causes a geoid low, anyway? Well, a geoid high, one of those gravity bumps, tells you there's a surplus of mass down there, something extra dense. But our gravity hole is a geoid low, and that points to a huge mass deficit. Something deep beneath the Indian Ocean has way less mass than the rock around it. And the big question has always been, what is it? You bet, this mystery kicked off a huge investigation that lasted for decades. For years, geophysicists were like detectives chasing two main clues, two totally different theories that tried to explain this gigantic patch of missing mass. So the first big theory looked up from the deep Earth towards the surface. It suggested that huge plumes of hot, molten rock were rising up from the mantle. You know, kind of like a lava lamp on a planetary scale. This hot rock is way less dense than cooler rock. So a giant plume surging upwards, well, that would create exactly the kind of mass deficit that scientists were seeing. But then there was this other really cool theory that pointed in the opposite direction, downwards to an ancient tectonic graveyard. The idea here was that millions of years ago, a massive, cold, and really dense chunk of an old oceanic plate, a piece of the lost Tethys Ocean, had sunk deep, deep into the mantle. Now hold on, you might be thinking, wouldn't a cold, dense slab cause a gravity high, not a low? And you'd be right to think that. But the secret isn't the slab itself, it's what the slab does when it gets down there. As these ancient slabs sank into the superhot mantle, they would basically get cooked and release all the water that was trapped inside them. This superheated water would then mix with the rock around it, lowering its density and maybe, just maybe, creating our gravity low. For the longest time, it really seemed like you had to pick a side. Was it the rising hot plumes or the sinking cold slabs? But the real breakthrough, the aha moment, came when scientists figured out it wasn't one or the other. The two clues were actually part of the same incredible, interconnected story. So check this out. Here's how it all fits together. It all starts with that ancient oceanic plate sinking into the mantle, finally coming to rest in a slab graveyard, right near the Earth's core. But here's the kicker. As these enormous, cold slabs plunged down, they acted like giant pistons, pushing all the hot, gooey material out of the way. That powerful disturbance squeezed and then unleashed plumes of less dense, hot material, forcing them to shoot upwards. And those rising plumes, that's the source of the gravity hole. The sinking slabs were the trigger, but the rising plumes are the cause. It's brilliant. You know, solving this 75-year-old mystery is about more than just checking a box. It gives us this absolutely stunning window into the hidden engine of our planet. It shows us how events from deep in Earth's ancient past are still shaping the very surface we live on today. So let's just run through the whole story one more time. We started with this wild idea that Earth's gravity is lumpy, and the biggest dip in that lumpy field is the gravity hole in the Indian Ocean. For decades, scientists were torn. Was it rising hot rock or sinking cold rock? And it turns out the answer is both. The sinking of an ancient pleat into a slab graveyard near the core was the trigger that forced hot, low-density plumes to rise up in response. The real takeaway here is just how connected everything is, from the deepest parts of our planet all the way up to the surface. So, the case of the Indian Ocean's gravity hole might be closed, but it leaves us with an even bigger, more exciting question. What other incredible secrets are still locked away in the deep Earth, just waiting to completely change how we see our own world?